So this session is related to refractive index. The term refractive index means ability of the medium to bend light. When the medium will try to bend the light, that ability of a medium is known as refractive index. There are three ways refractive index can be calculated. The refractive index can be denoted by formula refractive index sin I over sin R. This is possible, this formula is valid when the light is moving from air to glass or water. So if it travel from rarer medium to denser medium, from low density to high density medium, then we'll use a formula that the refractive index is equals to sine angle I over sine angle R. So example, you have a glass, a rectangular glass block, and the ray of the light strike this surface, and when it moved from air to glass, it bent towards the normal because the speed decreases. That's why it bent towards the normal. So when we work out the refractive index, if you want to calculate a refractive index, then the formula for refractive index moving from air to glass in terms of angle. So here it is example 30 degrees and this one is example 25. So how to work out the refractive index moving from air to glass? So refractive index is equals to sine angle I over sine angle R. So sine angle I, angle of incidence, that is equals to 30 degrees, and angle of refraction is 25. So sine 30 divided by sine 25. So you will use a scientific calculator here. And first thing, whenever you are using a scientific calculator, the mod should be in degree, like the angle should always be in degree. So it is sine 30, and that is divided by this is the value of sine 30, which is 0.59. So when we are finding the refractive index was sine angle I over sine angle R. So using a scientific calculator, you will work out the value of sine angle of incidence, which is 30 here. I put 32, but it is 30. So n is equals to sine 30 divided by sine 20. So sine 30 degrees, that is equals to 0.5. So we'll put 0.5. And sine 20 degrees, the second value is sine 20. So sine 20 is equals to 0.34 or 0.34. So 0.5 divided by 0.34. So refractive index, which is 0.5 divided by 0.34, that is equals to 1.47. So in this case, the refractive index will be 1.47. And refractive index does not have any unit, no unit for refractive index, because it is a ratio, it's a comparison. That's why the refractive index does not have any unit. So the first formula for refractive index, if it is traveling from air to glass, then we will use this formula. The second formula for refractive index, when it is traveling from glass to air, I is the angle of the incidence and R is the angle of reflection. Like if this is a glass, the ray incident, the ray strike the surface, and when it strike the surface, it slow down, decreases the speed, so bend towards the normal. So as it bend towards the normal, when we draw a normal which is perpendicular to the surface, so the angle between the incident, the normal and the incident, this is the normal, the imaginary line, the angle between the incident and the normal, that is called angle of incidence. So it is equals to 30 degrees. And angle of refraction here, that is 20. So when we want to find the refractive index, ability of this medium to bend the light, then the refractive index will be equal to sine angle I over sine angle R. Refractive index is sine 30 divided by sine 20. And when we work out sine 30 divided by sine 20, it is 1.47. But don't write any unit because refractive index is a comparison. It is comparison the ability to bend the light compared to that of air. So we can say that compared to air, this glass is having a tendency to bend the light 1.47 times or 1.5 times. So this is the first formula for refractive index, which is the ability of the medium to bend light when the light is moving from air to glass or water. The second formula for a refractive index, if the light is traveling from glass to air or water to air. So if a light is traveling from glass to air or water to air, what will be the formula of refractive index? Example, this is a semicircular glass and the ray of the light, when it was moving in the glass, it was moving slower, but as it move from glass to air, it speed increases. Imaginary line which is perpendicular to the surface or 90-degree to the surface, that is normal. The angle between the incident and the normal, that is angle of incidence. Example, this angle was 20 degrees. An angle between the normal and the refracted, that is angle of refraction. Example, that is 45. So we want to find the refractive index when the ray of a light is traveling or moving from glass or water to air. So originally it is in glass and now it is traveling in air. So moving from glass to air, the speed of the light increases. That's why it bend away from the normal. So the formula here, the refractive index will be equal to sine R divided by sine I. So what is I here? I is the angle of incidence. The first angle, so angle of incidence is 20 and angle of refraction is 45. So we will use this to work out the refractive index. So angle of incidence is 20 and angle of refraction is 45. So refractive index when moving from glass to air, that is sine R over sine I. So sine R, the angle of refraction, that is 45, and sine of angle of incidence, that is equals to 20. So whenever you are using a scientific calculator, always remember that your calculator mode should be in degrees. So it is in degree now. Then first sine 45. So sine and 45 degrees, that is equals to 0.707. So sine 45 is 0.707 divided by sine 20. So that is sine and 20 degrees. So sine 20 is 0.34 or 0.34. So 0.707. So 0.707 divided by 0.34. When we divide these two numbers, we'll get 2.07, the final answer. So 2.07 is a refractive index, and refractive index does not have any unit because it is ability of a medium to bend the light, a comparison compared to air, how much the medium can bend the light, that refers to refractive index. So if we are getting a refractive index 2, what does it mean? It means this material have a tendency to bend the light twice as compared to that of air. So refractive index, when we substitute the values, the sine 45 divided by sine 20. So after solving this, the final answer is 2.07. Is it clear? The concept of refractive index and how we can use the formula to calculate the refractive index. Now more examples related to calculation of the refractive index. So again, I'll write the formula. There are three formulas, but in terms of angle, there are two, like sine angle I over sine angle R. This formula, when it is moving from air to glass or water. And the second formula for refractive index is equals to sine R over sine I. That is when it is moving from glass or water to air. So these are the two formulas which we can use. Now some more examples related to calculation, because sometime you have to calculate the refractive index, sometime you have to calculate the angle as well. So how we will use these formula. Most of the question the light is traveling from air to glass. So this is a very common. But there are some questions in which the light might travel from glass or water to air. So you will use the opposite formula. Is it easy to remember? For example, if you don't remember the formula, so always remember the angle in a numerator will always be greater than angle in denominator. So example, if I don't remember the formula in exam, if you don't remember the formula, the light is moving from air to glass here. And the other example, the light is moving from glass to air. The imaginary line which is perpendicular 90 degree to the surface, that's called normal. So in reality, it's not there, it's just imaginary line. Say this angle was 40 degrees and this angle is 20. And here this angle is example 15 and the other angle is say 35. So we want to calculate the refractive index, and if in exam you don't remember the formula, you can also work out the thing is the denominator angle is always greater than the numerator angle. So when I calculate a refractive index here, so it will be sine 40 divided by sine 20. But when I calculate a refractive index here, two angles are given. One is 15, another one is 35. So when I calculate the refractive index, always a greater angle in numerator. So sine 35 divided by sine 15. So if you remember in this manner that in a numerator, always the value of the angle is greater than denominator. So it will be easy. So sine 40 divided by sine 20 will get the refractive index, but in the second case, we'll get sine 35 divided by sine 15. Sometime in the question, they give you the angle between the incident and the surface, but you always take the angle between the incident and normal. So if there was a question like a light strike the surface moving in air the light is traveling faster, and in the glass the light will slow down. So imaginary line which is perpendicular to the surface, that is known as the normal. So example, two angles were given. The angle between the ray and the surface is given. Like, so this angle was for 60, and this angle is 80. What is the angle of the incident? And so what is the angle of the incidence here? So how we can work out the angle of incidence? Angle of incidence or angle of refraction is always measured from the normal. So when we measure the angle between the incident, this is an incident ray, and this one is a refracted. So the angle between the incident and the normal, that is called angle of incidence. An angle between the refracted and the normal is known as angle of refraction. So what is the angle of incidence here? If the angle between the surface and the incident is 60, what is this angle? What will be the value of angle of incidence? So it will be 30 degrees. That's right. And what about angle of refraction? If this angle is 80, how much is the angle of refraction? So that is equals to 10 degrees. And why the angle of incidence not equal to, in a refraction, the angles are not same because the ray changes a direction. That's why the angle changes. So if you want to calculate the refractive index, because it is moving from air to glass, the formula to calculate the refractive index, that is n is equals to sine 30 divided by sine 10, or angle of incidence divided by angle of refraction. So we'll use a scientific calculator, sine 30 divided by sine 10. So the refractive index which we want to calculate, that is equal to sine 30 divided by sine 10. So sine 30, so this is sine, and 30 degrees, which will be 0.5. So sine 30 is 0.5. Then what about the value of sine 10? So this is sine in 10. So that is equals to 0.17. 0.17. Then we just simplify 0.5 divided by 0.17. So 0.5 divided by 0.17, or 0.17 is same as 0.17. So we'll get 2.94. So refractive index is coming out as 2.94 for this example. So the refractive index, when we substitute the values, it will come out as 2.94. Is it clear, this example? Sometime the refractive index is given and you need the angle. Like the question is, find the angle of refraction when angle of the incidence is 40 and refractive index is 1.5 or 1.6. When the light travel from air to glass. So light is traveling from air to glass. So whenever the light travels from air to glass, the formula for the refractive index which we use, that refractive index is equals to sine angle I over sine angle R. This is a formula whenever the light is moving from air to glass. So light is in air and it is moving to the glass or inside the glass. So what is the angle of incidence? That is given 40. So the formula, that refractive index is 1.6. It's given here 1.6. So refractive index is 1.6 is equals to sine angle of incidence is 40. So it will, I'll write sine 40 divided by sine angle R, or sine angle sine R is equals to sine 40, because sine R is divided, other side it will be multiplied, and 1.6 is multiplied, other side it will divide. So it will be sine 40 divided by 1.6. Now what is the value for sine 40 divided by 1.6? So refractive index for sine r is equals to is sine 40 divided by 1.6. Yes, Abdullah, that's right. So first we'll work out the value for sine. So it is sine 40. So what is sine 40? Sine 40 is 0.64. So in place of sine 40, we write 0.64 divided by 1.6. That is equals to sine r. So 0.6 divided by 1.6, that is equals to 0.40. So this value is 0.40. That is equals to sine r. But in the question, we need r only. So if we need r, then r will be equal to, because this sine will move other side. So when sine move other side, it will become sine inverse. That's called sine minus 1 or sine inverse. So r will, this is a mathematical way to solve this trigonometric function. Like if sine theta is on one side, I want to move this sine theta to other side. So it will become sine inverse. So same thing happen here. Sine r is equals to 0.64. So r will be equal to sine inverse 0.64. What is sine inverse? Sine inverse means on your scientific calculator there is a button known as shift. So you will use that button shift. But I will have invert here, INV. So I'll press invert sine. So invert sine means arc sine or sine inverse. So sine inverse 0.4. So sine inverse 0.4. So that is 23.57. So the value of the R will be equal to 23.57 degrees. Is it clear? This way of finding the angle of refraction. So whenever you're finding the angle at the last, you have to take the sine inverse, because sine is on one side. When it moves to other side, it will become inverse. So sine r is equals to sine 60 divided by 1.6. So that was 0.4. So sine r is 0.4. But we need only r. So if we need only r, the sine will move other side. And when the sine will move other side, it will turn into sine inverse. So it will be sine inverse 0.4. And this sine inverse 0.4 is 23.57. So the value of the r will be equal to 23.57. Is it clear? This is the same thing, same question. We work out. So sometime in the question they give you refractive index and angle of refraction. You have to work out angle of incidence. Sometime you have angle of incidence and refractive index. You have to work out angle of refraction. But the technique remains the same. The method remains the same. Only difference what you will take at the last, you will just take sine inverse. So this is a mathematical way of solving the it. When we have sine r, the sine r is 0.4. Okay, so we are finding r only. We need r. When we need this r, like we need this only r, so sine will move to other side. So when sine, always remember, when sine move to other side, we write that as sine inverse. And how we write sine inverse on calculator, the scientific calculator, there is a button. First you will press a shift. There's a button called shift, and then sine is there on, and top of this sign it is written sine inverse. So when you press the shift and you press this sine button again, it means you are calculating a sine inverse. So it will be sine inverse 0.4, and sine inverse 0.4 will be equal to 23.57. 0.57. Another example I will give. So it is always fixed. Whenever you are finding the angle, you always take a sine inverse. So if I say calculate angle of incidence when angle of the refraction is 24 and the refractive index of glass is 1.5 when the light travel from air to glass. So light is traveling or moving from air to glass. So whenever the light travel from air to glass, the formula for the refractive index, that is sine I divided by sine R. So in the question we need angle of incidence, so we need this part. The angle of refraction is 24 and the refractive index is 1.5. So refractive index is 1.5 sine I divided by sine 24 because that is 24. Now we'll use a scientific calculator. So on the scientific calculator, the refractive index, uh, the formula as it is moving from air to glass, so it is sine angle I over sine angle R. And the angle of incidence in the question that is given, we have to find an angle of refraction is 24. So this is 1.5 sine I divided by sine 24. So we'll work out sine 24. So sine 24, that is 0.4, 0.4. So 1.5 is equals to sine I divided by sine 24, that is 0.4. So this will be 0.4. The 0.4 is divided, other side it will be multiplied. So it will be 1.5 multiplied by 0.4. So sine I 1.5, that is 1.5 times zero point 0.4 equals to 0.6. So this value is 0.6. So 0.6 is equals to sine I, or we can say sine I is equals to 0.6. It's the same thing. But we need only I. We need angle of incidence. So this sign should be moved. So when we move this sign to other side, it will always become inverse. So it means I will be equal to sine inverse 0.6. How in on calculator, scientific calculator, we write sine inverse? So we press the button on your calculator. This is a Google calculator. It's written in INV, means inverse. But on your scientific calculator, it will be written shift, SHIFT. So first we'll press a shift. I will press inversion. Then you can see now it is sine inverse, cos inverse, tan inverse. So I have to take sine inverse. So I press sine inverse. Here on sine, this calculator, it is showing arc sine. Arc sine is same as sine inverse. On your calculator, how it will be written? It will be written like sine inverse. It's the same thing. And what is the value? So sine inverse 0.6. So sine inverse 0.6. So that is equals to 36.8. So value for angle of incidence will be 36.8 degree. Is it clear, this example? So sine I divided by sine 24 was 0.4. that was it is divided, other side multiplied. So 1.5 multiplied by 0.4, that is equals to sine I. So that this is 1.6, 0.6. So 0.6 is sine I. But in the question, we need angle of the incidence. We need the angle of the incidence, so we need I here. So if we need I, sine will move other side. So if sine will move other side, it will become sine inverse. So sine inverse 0.6, that is equals to 36.8. So 36.8 will be the 87 or 36.9. That is the angle of incidence. So sometime the refractive index and angles, one of the angle is given, you have to find the second angle. Sometime both angles are given and you have to find the refractive index. Same way, if you want to calculate, there's another formula for refractive index in terms of speed. So refractive index is equals to speed of light in air divided by speed of light in medium. And this formula is fixed, it does not change. Even the light travel from air to glass or glass to air, this formula remains same. So refractive index is equals to speed of light in air. Refractive index is denoted by n. Speed of light is denoted by letter C, and speed of light in a medium is denoted by v. So n is equals to c by v, where c is the speed of light, which is a fixed value, 300 million meters per second or 3 exponent 8 meter per second. So if I say find the refractive index, find the refractive index when speed of light in glass is 2 into 10 raised to power 8 meter per second. So the refractive index, when speed is given, they don't give you the speed of light in air. So you have to memorize the speed of light in air, which is 3 exponent 8. So when we are calculating the refractive index, in this example, the refractive index is speed of light in a air, which is 3 into 10 to the power 8, divided by the speed of light in a glass, which is 2 into 10 to the power 8. So when we divide the two values, 3 exponent 8 divided by 2 exponent 8, so we'll get as 1.5. So this is the refractive index of this glass. So three formulas are there for refractive index. One is in terms of, two are in terms of angle, and one is in terms of speed. The speed formula does not depend on even a light travel from air to glass or glass to air. It won't change. But the angle formula is depending on if it travel from air to glass, it is sine angle I over sine angle R. And if it travel from glass to air, then the formula will be opposite. Now some questions related to topic, the refractive index. So this exercise related to refractive index, the bending of the light. Now in this question, a light, the diagram shows a light travel from air to glass. So whenever the light travel from air to glass, the refractive index is equals to sine angle I divided by sine angle R. So what is angle I here? Angle between the incident and the normal, that is called angle I, angle of incidence. And the angle between the refracted and the normal is known as angle of refraction. So n is equals to sine angle I over sine angle R. So n is equals to sine angle I, that is W, and sine angle R is x. So it will be sine W divided by sine x. So D will be the right answer. Only we'll do the questions related to the concept of refractive index. So when the light travels from air to glass, the speed of the light changes or decreases. So in this question, a light travel in vacuum, then it enter a glass. The speed of the light in a glass is 2 exponent 8. Which statement about the speed of light is correct? The speed of the speed in a vacuum is 1.5 times the speed in a glass. So when you compare the values, the ratio, you will find the first statement to be true, because the speed of the light in a vacuum or air, that is 3 into 10 to the power 8, that is in air or vacuum, and the speed of the light in a glass, that is 2 into 10 to the power 8. When I take the simplest ratio, when I simplify this, I take a simplest ratio, I divide by smallest value. So what is the simplest ratio? 3 exponent 8 divided by 2 exponent 8, that is 1.5. And this is 1. So what it shows that the speed of the light in vacuum is 1.5 times the speed of the light in a glass. Like comparison, when we compare them, or light is traveling faster in vacuum as compared to that in glass. That's the reason A is the correct answer. Why not B? Because in B they mentioned the speed in the glass is same as speed in vacuum, so that is wrong. Why not C? Speed in the glass is 1.5 times, like speed, it means the speed in a glass is more, but that is wrong. Speed in a glass, when the light travels from air to glass, speed decreases. Then speed of the light is 1 exponent 8 times, so that is also wrong. It is not 1 exponent 8 times more than the vacuum, it is 1.5 times less than the vacuum, or we can say the vacuum is 1.5 times more. So whenever light travels from air to glass, the speed of the light will decrease, sorry. Some of the questions are related to topics which we will discuss later. That's why I did not solve all the MCQs. I'm just solving the relevant question related to refractive index. Now in this question, the light travel at a speed of 3 exponent 8 is strike the surface of a glass block and undergoes a refraction. The diagram shows a ray of a light before and after it enters the block. What is the speed of the light in a glass? So to get the speed of the light in glass, first we should know the refractive index. How to get a refractive index? Moving from air to glass, so it is sine I over sine R. 55 and 33. So we have to take or find the refractive index. The refractive index is equals to sine 55 divided by sine 33. So the sine 55 is 0.89, 0.81 divided by sine 33. So sine 33 is 0.54. So 0.81 divided by 0.544, that is 1.48. So when we work out the refractive index is 1.48. So, but in the question, we don't need refractive index, we need the speed. So first we'll find the refractive index as it is traveling from air to glass. So sine 55 divided by sine 33. So sine 55 divided by sine 33, that is 1.48. Now there is also another formula of a refractive index which relate the speed, that the refractive index is equals to speed of light in air divided by speed in a medium or speed in glass. So refractive index we work out 1.48. The speed of the light in air, that is fixed, you have to remember. Some question they provide, some question they give this value, some questions you have to use from your side, so it's better you memorize this value 3 exponent 8 divided by speed of a light in glass, that is unknown, or x. Cross multiply, x will move there, 1.48 will come there in division, so 3 exponent 8 divided by 1.48. So when we simplify 3 exponent 8 divide, it is approximately 2 into 10 to the power 8 meter per second. Is it clear this question? That how we work out the speed of the light in a glass by using the refractive index.